Hello, good evening. If you're wondering why I'm walking so gingerly, don't get any ideas. I've just sprung my back. Welcome to the Spark Summit meetup, our 14th Spark Summit, Bay Area Apache Spark Summit. This is our 14th summit. We have come actually a long way. My name is Jules Damji. I am the Spark Developer Advocate and the Program Chair for Spark Summit. So on behalf of the Spark Summit, I want to welcome all of you. How many of you are actually attending the Spark Summit tomorrow? Wow, a majority of them. Well, welcome aboard. Thanks a lot. Now, I'm really, truly heartened to see so many of you here today. I mean, this is really the heart and the pulse of any open source project. It's actually community. It's people like you who come out there and advocate, who go out to conferences and talk, who come and actually share knowledge, who actually take the knowledge back to the community and start talking about it. Because if you look at historically of any open source project, it's actually the community. Whether it's a TensorFlow project, whether it's Linux, whether it's Apache Kafka, whether it's Apache Spark, it is people like you who actually make a difference in making the project really successful. So give yourself a big hand of applause, really. And in many ways, you truly are the advocates. And as I found out this particular morning, and I normally do that every morning, I go up to the meetup page and find out how many new meetups have actually sprung up. This morning, we have had 600 Apache Spark meetup around the world, and over 500,000 people who are members of the Apache Spark group. Now that's truly a global movement, and I think it has to be because people like you actually are dedicated for the last 10 years to flourish this community globally. And you see that actually happening in TensorFlow, you see that happening all around the world. So give yourself another hand as well. And this particular meetup group actually this morning hit up about 11,000 people. So we are one of the largest Apache Spark meetup group in the world, I can claim that, and it's all because of you. Now, I got a couple of announcements and a couple of acknowledgements. First and foremost, I really want to thank the Databricks Diversity Community Group who actually has set up this particular meetup group. Do we have members of that group over here? Can I see members of that group from the diversity community? They're hiding, they're shy, but there you go. Well, give them a big hand. They actually organized this event, and they also have organized other events which are actually related to women in unified analytics. There's going to be a breakfast tomorrow, and there's going to be a panel discussions at the Intercontinental, which is down the road. So make sure that you actually show up and give them a support. There are going to be two Birds of Feather sessions. Those of you who are old enough, Birds of Feather session has actually emerged from the community. You come out there and ruffle some feathers and talk about Spark and talk about everything else. So there are going to be two sessions, one tomorrow, one on Thursday. Tomorrow we have Apache Spark on Kubernetes. So if you're actually interested to find out how Spark works on Kubernetes, come and attend those sessions. Those are during lunchtime. There will be signage on the particular table as you walk around that says Birds of Feather. And then on Thursday, we actually have another one called Distributed Apache Spark Lib on Apache Spark. So that's going to be on Thursday, so look for it. And obviously, no conference is devoid without a huge party. So we're going to be having a party in Expo Hall on Wednesday night. Please join us. There are going to be lots of activities. And this year, in order to sort of expand the developer experience, we have a developer lounge on Wednesdays and Thursdays. These are going to be open sessions, lightning talks during lunch and during break sessions. We're going to be having a customary bar, or advisory bar, where you'll be serving Spark shots. I meant that figuratively speaking, but you can actually book a particular appointment and have your Spark questions answered. And we'll have an open sessions for Ask Me Anything about Spark, or anything about machine learning, or anything about AI, hosted by Matthias Zaharia and Renault and Shangri. These are one of the original creators of Apache Spark, so and MLflow, and you hear about from them. So check your sessions, developer lounge during lunch breaks and so on. And finally, talking about advocacy and talking about a community, it's really a pleasure for me to actually have here as the first speaker, Paige Bailey. Paige is a senior developer advocate at TensorFlow, and her passion is actually to talk to developers and to bring about how TensorFlow is actually working. A graduate of Rice University, where she actually, after that, she actually worked as a planetary, as a data scientist for Chevron, and then moved on to do some software engineering work in the office of CTO in Microsoft. And now, more recently, she's heading all the efforts for TensorFlow to bring TensorFlow to the developers like you. So please give a warm, warm welcome to Paige Bailey.
Thank you so much. Awesome. Excellent. I'm so delighted to be here tonight to talk to you all about TensorFlow and about some of the new things that we have planned for it as part of TensorFlow 2.0. So I guess my first question is, how many of you have tried using TensorFlow before? Some hands. How many of you are machine learning practitioners, like you do it for your day job sort of thing? And how many of you have no experience with machine learning at all? So a few hands, but I see the majority of folks have at least some familiarity with machine learning, some familiarity with deep learning, and will probably be able to sort of catch the drift pretty simply. If I go too fast, always feel free to ask questions. I'll be looking for hands, and I'll also have some time afterwards to answer any questions from the audience. So with that, let's get started. Gentle introduction to TensorFlow 2.0. I am Paige Bailey. I'm a TensorFlow developer advocate at Google. Previously, I was at Microsoft, as Jules mentioned, working in the office of the CTO, and then prior to that, doing machine learning. And before that, I was a data scientist at Chevron for about 5 years, and before that, worked as a planetary scientist for NASA projects. I'm also a dynamic web page pretty much everywhere on the internet. Paige spelled like my name. So if you want to reach out after this, feel free to reach out to webpage@google.com, pun intended, or dynamic webpage on Twitter or elsewhere. So TensorFlow has been incredibly popular. It's sort of exploded in popularity over the last 3 years since it was open sourced. Here's a map of GitHub stars, which I'm not sure why people use as a metric. But it's sort of displaying all of the locations around the world where people are using TensorFlow and have liked it enough to give it a like on GitHub, including Antarctica. And I am not sure what people are doing with TensorFlow in Antarctica, like maybe deep learning on penguins or something. But yes, so sort of an explosion of popularity since it was open sourced. We've had 41 million downloads, 50,000 commits, almost 10,000 PRs, and almost 2,000 external to Google contributors, which is really kind of magical to see. We've also released a number of additional features since it was first open sourced as a product. So for folks who might not be familiar, TensorFlow is sort of an end-to-end machine learning framework that was used at Google internally under a variety of names. So you might have heard of Sybil or distbelief, and everything that uses machine learning for us, so the autocomplete that you see for email, the speech to text that you experience on your Android phone, the top filtered results for search, all of the machine learning functionality that you experience from Google products is powered by TensorFlow. And a few years ago, Jeff Dean, who's amazing, sort of decided that we were going to open source it. And since he's Jeff Dean, everybody said yes. And since then, we've released GPU support. We've also included TPU support, so both for a single TPU and a cluster of TPUs. CUDA support, right now with 2.0, we're on CUDA 10.1. We've had higher level APIs, so in a variety of forms. You might have heard of estimators, and some of the other tools like Slim that were released over the years. And we've also included a number of other products that kind of extend the capabilities of TensorFlow to make it not just a numerical computing platform, so kind of similar to NumPy, but something that you can take a model and deploy it on a mobile device or deploy it in a browser. So as you can see, lots and lots of sort of advancements over the years. And we've used it very successfully internally. So for data center efficiency, for localization in Google Maps, for portrait mode on Google Pixel, and many others. And the community has used it in ways we could have never imagined. So here you see a custom beat generator created in JavaScript, and using a deep learning model, you just drag along the image, and it generates a synthetic beat for you. And you can imagine this tool in particular is called Magenta. If you're a musician, you would be able to do something like create a melody, and then automatically create a bass guitar accompaniment or create a drum accompaniment or something of that nature. So really sort of seeing an explosion of applications, not just for production use cases, but also for creativity and artistic experience. And in the sciences, it's even more exciting, right? So here you see AlphaFold, which was created by DeepMind. They entered into the protein folding Olympics, which I wasn't really aware was a thing. And on their first try, their deep learning model was able to blow apart the accuracy of sort of bioinformatics and genetics researchers with just kind of a basic model, not even fine-tuned. So being able to see this sort of application as an earth scientist, I'm really passionate about the climate research that's being done with deep learning and sort of the additional applications that you can see in terms of predicting earthquakes and sort of building the tooling that we would be able to use to not necessarily to reverse, but to better understand the changes that we've experienced in climate. So I asked before how many people have used TensorFlow. And if you raised your hand, I'm sorry. So I started using it in 2015, whenever it was first released, whenever they had that weird, wonky, trippy sort of, deep dream situation where you could make everything kind of look like a puppy face. And the code looked a lot like this. And if you're a Python person, this is not intuitive in the slightest, right? Like, so you can assign some values to variables right up at the top, but you can't immediately inspect them. So you can't really use them. You have to start a session. So you have this with tf.session as sesh command. You have to initialize those variables in order to be able to use them. You have to do something like starting queue runners, which everybody hated. Like, nobody liked it internally either. And then instead of dealing with data in a rational way that you might expect if you were familiar with pandas or something, you would have to create these feed dicks and do special batches of data, and it was all very frustrating and not particularly well documented, and most people were just kind of like, nah, man, it's cool, I'll go back to scikit-learn. And yeah, y'all play hard with your GPUs, I'm happy with my random forests or my gradient boosted trees or whatever. And so this was the experience for TensorFlow from kind of 1.0 to pretty recently. And we've learned a lot since then. So that's the good news. With TensorFlow 2.0 alpha, which was just released earlier this year, so around February, we've adopted Keras, which is a friendly higher-level API, as our recommended higher-level API and our recommended way to interact with TensorFlow. So if you haven't experienced Keras before, it's the thing that made TensorFlow usable to me. So I came from scikit-learn, where you can create a model, train it, run it, use it to predict values with like 6 lines of code. Keras feels very similar. And right now, it's the recommended way and also the most documented way to build models with TensorFlow alpha. We also enabled eager execution by default. So you can do amazing things, like add 2 numbers together and immediately see a response. And so instead of having to assign variables and then initialize them before you could even start playing with them, you can immediately see the results of your work. And this helps a ton in terms of debuggability and also sort of understanding what your model is doing over time. We've also removed duplicate functionality. So you might have realized that the TensorFlow is an end-to-end machine learning platform, which means it does a lot of things. That also means it has a lot of endpoints, or it did. About 4,500 was what I counted the last time. And we've reduced the footprint of that substantially. So all of the endpoints that maybe were doing the same things with inconsistent sort of naming conventions, we've merged them. And then made those naming conventions consistent. We've also bucketed them, so instead of having tf.foo, you now have something like tf.math.foo or tf.signal.foo. So it really makes things a lot more understandable to get started. We've also begun the process of modularizing TensorFlow, so instead of installing this big, bulky thing, you can just pip install it component-wise and only use the pieces that you need, which is, for people who hate Bazel, and I think that's pretty much everybody, it makes it a lot more straightforward and friendly to get started. We also still have the full lower level API. So if you were one of those people who really enjoyed working with TensorFlow before, you're still able to do precisely what you were able to do before. Even though it's sort of default dynamic graphs now instead of static computational graphs, you can still wrap things in TF functions and make it work the way that you would expect with earlier versions of TensorFlow. All of this is kind of a higher level architectural diagram. You have a number of processes that you would do for training, so reading and pre-processing data, et cetera, probably using Spark a lot for the data pre-processing tasks. Everything is sort of bolted together into a saved model, and then that saved model is deployable across the entire ecosystem without you having to do anything. So you would be able to deploy it to a mobile device or an embedded device. You would be able to deploy it to a browser or to a server, or you could just do inferencing local to your machine. And again, this is a much more straightforward path than before, where you had a number of ways to save models, and it was really, really difficult to do it sort of consistently and in a reproducible way. And we have a number of language bindings, so no Scala if you're a Scala person, but Python, C#, certainly, F#, even Rust, R, Java, C, sort of pick your poison. And this is just, again, just sort of an overview of the training workflow. You have TF data for straightforward data ingestion. Historically, you might have had like 500 lines of code to do data pre-processing and ingestion. Now it's more like 5 or 6 lines. Keras and pre-made estimators is the higher level APIs. You can do training with eager execution, visualize it immediately with TensorBoard, and then deploy everything as a saved model. And the data loading process looks very similar to, again, if you're coming from the PyData community. We have a new product called TensorFlow Datasets. This is a bunch of prepackaged datasets that make it easy to include as part of a machine learning model. You just pull them in, define a training and test set, and then can immediately start using them in batches for any neural network that you create. And I also want to make sure to point out that TensorFlow is not just for neural networks. It's also for traditional machine learning models and any sort of scientific computation that you care about. So if you're into matrix factorization, you can do that. If you're into differential equations or numerical computing, you can do that. And there's probably a higher level API that will help you with that task. And then these are just some examples of the TensorFlow data sets that I mentioned before. I think we have something to the effect of like 90 available for you to use right now. TensorFlow also loves Keras, as I mentioned before. And instead of having that weird, wonky situation that I was showing where you initialized variables and then you had to run them with sessions and queue runners and such, this is what it looks like to create a complete model now, right? So you would have a training set, a test set. You would build your model using just that single model command, so you have several layers. If you've done any sort of deep learning training, you've probably recognized this as MNIST, which is the digit recognizer, right, from 0 to 9. You can sort of, the teller, right, is that you're using softmax as your activation. And softmax tells you that it's a categorical kind of classification problem, and that you have 10 categories, so it's 0 to 9. You can specify optimizers, losses, even custom losses, and then whatever metrics that you care about. And here we're talking about accuracy. Epics tells you how many times you want to pass over your data set, and then you would evaluate your test data set against the model that had been trained. And that's it. So that is all that is required to do deep learning with TensorFlow today as part of 2.0. And since we're Google, we make it scale, right? So historically, using clusters of TPUs, clusters of GPUs might have been very, very frustrating. Now, if you want to distribute this entire model, it's 2 lines of code. So you define a strategy as part of distribution strategies. You put your model in a strategy scope, and then this can be deployed across a cluster of CPUs, GPUs, or TPUs, which is, again, kind of magic if you're used to the big, bulky thing that you might have played with before. We also know that transfer learning is very, very useful to people in industry, and it's about to explode in terms of business value. So we've open sourced all of our models and model components as part of TensorFlow Hub. You can take a model that, so for example, the speech-to-text one that I was referencing before, or the models that sort of recognize puppies and pictures, and use them immediately for yours at no charge. So all of the models that Google has available available internally. You can sort of access them and model components as well for your projects. And this is tfhub.dev, if anybody is interested in going to check it out. We also have, like I mentioned, flexibility for every use case, full control with subclassing and custom loops. So if you're a researcher who's kind of like, nah, man, I'm too cool for Keras. I got to do some subclassing. I've got to do more hipster stuff in order to make my models go. You can create sort of custom classes as part of Keras to give you the flexibility you need. And again, if this doesn't meet your needs, you can also always return back to raw ops or to combat v1 with TensorFlow 2.0. We've also embedded TensorBoard within Google Colab, and if we have time towards the end, I'll go into a demo of this. But it's really cool to see. So TensorBoard, historically, you'd have to do localhost 6006, and it was very frustrating. You would have to kill processes, and that. And if you were working kind of in a like on a VM on the cloud, it was difficult to get started, frustrating to kind of get all of the permissions and sort of ports where they needed to be. Now you can just use it as part of a Colab or a Jupyter Notebook instance. So the TensorBoard magics, you just preface it with a percentage sign, and you're off to the races. We've also included built-in performance profiling, both for GPUs and for TPUs. So if you want to know how your hardware is performing as your model trains, that's an option. We've improved the documentation, both the API documentation and the tutorials and quick start guides. And we've also attempted to increase performance for training, and we anticipate these numbers to get even higher. So I've seen people with automatic mixed precision, so sort of a tooling created by NVIDIA, get like 8 times speed up using 2.0. And it's really kind of remarkable to see. We've increased the number of products in the ecosystem. So here you have probability, agents for reinforcement learning, ranking, text, federated, and privacy. We've created TensorFlow Extended for end-to-end machine learning. So one of the things that I got most frustrated by when I was working in industry was that I would create this beautiful model. It would be in Python using scikit-learn, or it would be in R using like one of the caret bits of functionality. And it would be perfect, well, not perfect, but it would have an accuracy that my boss was okay with, and it would do precisely what I needed it to do. I would get endorsement from all of my stakeholders. They would say, yes, we should deploy this. And then I would hand it off to a DevOps team who would refactor the entire thing in like C++ or Java. My performance would tank. And it would also be very, very difficult to update over time. It was also really, really difficult to get the metrics back that I needed to make sure that my model was doing what it was supposed to do. And it was really difficult to keep a handle on the data that had been input to the model in the first place. So TensorFlow Extended, the mentality for that, and again, it's what we use at Google internally, is that all of that is needlessly frustrating. You should be able to create a model and deploy it using the same language, using the same framework. And you should be able to obtain metrics and model analysis metrics and metadata for that model over time as well. So everything that you would need to safely deploy a model to production, TensorFlow Extended gives you. And as of today, it is all open source. So it's available for you to use in your business, on any cloud that you choose, and with any service provider. So like I said, TensorFlow Extended, big, huge thing. You can run it on a variety of infrastructures. You have a number of products available as part of it. I encourage you to go and read the paper as well as to read the docs. It's really cool to see in action. The TensorFlow Lite, I already mentioned before a little bit about being able to do deep learning directly on a mobile device. So not so much training as inferencing, but it's still pretty cool. And also, they've done a number of performance enhancements for speed, not just for CPUs on mobile devices, but also for GPUs and even edge TPUs. And edge TPUs are now available for you to purchase as well as part of Coral. TensorFlow JS. Actually, I kind of want to do a demo of this. So I mentioned before, and my computer promptly locks me out. Maybe that's a sign I shouldn't do the demo. annoying the demo gods. But I mentioned before, TensorFlow.org has had a revamp, and one of the products available that you can look at as part of sort of our resources in our Learn section is TensorFlow.js. And TensorFlow.js is machine learning training and also inferencing directly in a browser. There are a number of demos available for you to try, and I encourage you to go and take a look at all of them. But if you haven't ever seen, for example, PoseNet in action, it's really kind of compelling to notice all of the capabilities that it has. So here you can see it automatically recognizes my arms, kind of my torso. And if I zoom in a little bit, it recognizes specific locations on my face, right? So the center of my eyes, my nose, my ears. And this is all out of the box. And the way that you would incorporate it into any one of the web applications that you would use at your work is just by including the script tag, right? So you're pulling in a TF.js model called PoseNet. Again, out of the box, you're not expected to do any sort of training. And I really think that this sort of move towards packaged AI models, packaged sort of open source models in particular, where you can do transfer learning if you need to do a more nuanced task, or just like to just sort of include this as part of your mobile applications or web applications out of the box is the path forward. I don't think it makes sense to expect everyone to know how to build the latest and greatest capsule network when you can just sort of take something that somebody's already created and then use it immediately to recognize your business value. You should be concentrated on sort of the particular problem that your business is facing as opposed to attempting to suss out what the latest and greatest shenanigans is with the latest and greatest paper. But yeah, so TensorFlow.js, variety of models available. I encourage you to go check them out. Everything that you see for TensorFlow.js is available for TensorFlow and for TensorFlow Lite as well. And the entire ecosystem is sort of displayed there. And this is the question that we always get. So how do I upgrade, right? Like you make this sound great, I'm sold, I'm hooked. How would I go about converting all of my existing TensorFlow 1.whatever models to 2.0? And we've tried to make it as easy as possible. So the biggest change is that contrib is no longer included as part of TensorFlow/TensorFlow. Contrib was kind of this big, hairy catch-all for community contributed code that was not supported. So it might work in like 1.2, but it doesn't work in 1.13, stuff of that nature. We've created migration guides and best practices, and we also have a conversion script upgrade utility called TF Upgrade v2. And what this is all you would have to do is export a Python file or a Jupyter notebook. So here you see an example of using an RNN. You would run the TF Upgrade v2 command line tool with the name of the file that you want to upgrade and what your expected file path name would be. It spits out a whole bunch of business about changed API symbols, renamed things, and also a report.txt file. And you can see detailed information about renaming symbols for you, about adding keywords to specific functions, about renaming things with compat.v1, which means there isn't an equivalent endpoint in 2.0, but you can still use the backwards compatibility mode and everything should work fine as usual. And then you're able to run your model as expected. And it should give you precisely the same performance and precisely the amount of training time that you experienced before. But if it doesn't, that's a bug, and you should file it and let us know. But you should see precisely the same results that you were anticipating. And we also have a machine learning GDE who created an example online, tf2up.ml, that allows you to take a Jupyter notebook, to take a particular location on GitHub or a link to any sort of Jupyter notebook file and immediately see a notebook diff expressed in a browser. So that's also pretty cool to see. And if you want to learn more, tensorflow.org/alpha has pretty much everything you would need to know. We want to release our final RC branch in spring, whenever spring happens to be. So this is a very nebulous term, but pay attention to the GitHub repo, because it should be approaching pretty soon. And we also have all of our progress available as a GitHub tracker. So if you want to have any sort of insight into what's happening with TensorFlow, all of the development work for our developers is transparent. You can ask questions and get responses from TensorFlow engineers immediately, or maybe like within a day. But I mean, they're not like right there, but they should respond between 24 hours. And it really is all about community, as Jules was mentioning. So we're doing something called Google Summer of Code. We're pulling in a lot of students from all over the world, part-time and full-time students, to work on TensorFlow projects and to get paid. We're really excited about this. We're doing a Powered by TF challenge, which you can still participate in on tensorflow.devpost.com. You can win an all-expenses-paid trip to TensorFlow World if you build something cool with TF 2.0. And also get to present your project directly to the TensorFlow engineering team. So the person who's responsible for TensorFlow, you would be able to sell your project, or, well, not sell it, but like to be able to show it to them and to potentially get it included as part of the organization. We've released a Udacity course. It's completely free. There are 14 segments planned, everything from TensorFlow JS to TensorFlow Lite and Serving. And highly encourage you to go and take a look. We're doing this in collaboration with Sebastian Thrun. We also have a global doc sprint that occurred on April 6th and another one that will be on June 1st. And if you want to get started, I encourage you to go build. So pip install pre-u TensorFlow and let us know if you have any questions. So with that, thank you so much. And let's get started. Yeah.
Thank you. Thank you, Paige, for that very effective and very persuasive. I'm sure you guys have a lot of questions. So I have a bad back. I'm not going to run around. I don't care about putting steps on my Fitbit. But we have a mic here in the center. If you have any questions, do you mind just lining yourself up for questions? We have about 13 minutes before we have a second speaker. So feel free if you have any questions about TensorFlow. And just to plug Paige's, she's also giving a tutorial on Thursday?
Yes.
Yes.
2 hours.
2 hours of tutorial, or 1 hour and a half. And so you'll get some hands-on experience about, how to actually write some TensorFlow 2.0. So that'll be actually great. Anyway, go ahead.
Yeah.
Yeah, it's a quick question. TensorFlow for general scientific computing work. That's a really interesting thought to me. I'm curious about performance, like out of the box compared to like compiled MATLAB or Mathematica or something. Is it competitive?
Gotcha.
And then how far can you go? If you.
So that's a great question. So MATLAB is single-threaded, which is, I think you might have the ability to do parallel processing now, but it's if I remember correctly, it's kind of frustrating to get started. TensorFlow is much more performant on specialized hardware than MATLAB would be. And then, for example, scikit-learn, I know that's used very widely in the earth sciences, very widely in the biosciences. It's also restricted to just CPU programming. And they don't really have support for GPUs on the roadmap. So if you want to be able to leverage accelerated hardware, GPUs, FPGAs, TPUs, TensorFlow is really kind of at least in my opinion, it's the most straightforward path to get started with distributed training and with training in that manner.
But on straight CPUs, you'd say it's competitive?
I would say that it's competitive, especially if you're using something like the extended tooling XLA and those sorts of tips and tricks. CPUs would be great.
Next question. Thanks.
Hi, thank you for your talk. I just had a quick question, which was, is there a plan for open neural net exchange, ONNX?
ONNX, yep.
Right.
Yeah, so that's a great question as well. ONNX is, I love the idea of ONNX, of being able to have sort of this data transfer format that's consistent across every neural network architecture, or every sort of machine learning architecture even, like being able to take a scikit-learn model and then port it to TensorFlow or port it to PyTorch or wherever the heck you want to put it. The problem is that in terms of functionality, all of these different frameworks have different capabilities, and sometimes there's not a one-to-one map across them. So if you have a model that's been built in something like TensorFlow that does something that isn't necessarily possible in a different framework, then there's not really a way for you to map that against. There's also a problem with stability of APIs. So right now, all of the model frameworks are changing very rapidly. And if, like 2.0 just got released and it supports static and dynamic computational graphs, and PyTorch 1.0, I believe, just got released. And it's also, working very hard to increase the number of features. And so all of these things are still in constant flux, which makes it really difficult to standardize on a data transfer format when everything is still so wildly changing. So I think that whenever everything stabilizes, so whenever we've kind of settled with each of the frameworks on this is our API pattern, here's how it's going to be for a while, I think then Onyx would be a fantastic idea. But until then, I'm going to concentrate more on building features for TensorFlow than for building features for Onyx. Does that make sense?
Yep, that makes sense. Thanks.
Cool. Thanks.
Thank you for a very informative talk.
Thank you.
The question is there any development at Google for TensorFlow and FPGAs
Yes.
in the interest of versus GPUs in terms of power versus the ASIC-based solution in terms of flexibility and cost? This especially applies to the edge.
Gotcha. So the question was about support for FPGAs. TensorFlow certainly runs on FPGAs. I personally really dislike programming for FPGAs because Verilog is painful, and C++ is kind of if you want to be able to have something is frustrating whenever the friendly language to program is C++. Or at least personal opinion. I'm not a C++ aficionado. But FPGA work certainly happening. Edge TPUs, if you're interested in low power inferencing solutions, I would strongly suggest you take a look at those as well. But TPUs, FPGAs, GPUs, clusters of all of the above, CPUs, clusters, all of those, including supercomputers. There's a project called TensorFlow Mesh, that's all about training on supercomputers, which I didn't know were still a thing either.
We found out about it at the Dev Summit when the guys from UK came and
Yeah.
presented the mesh, yes.
It was so cool. But yes, so if you're interested in development work for FPGAs, certainly would be delighted to hear from you.
Okay, come to our talk on Thursday about
Excellent.
automatic programming of FPGAs.
Yeah,
Thank you.
you won't be disappointed.
It feels backwards to ask, but is Scala support following Python support in this case?
Is Scala support?
Will it show up for TensorFlow?
So that's a great question. I know that nobody internally is working on it. However,
Do you want to file a PR request? Because it's all about community.
yes. So there are a number of special interest groups that are focused on language bindings for TensorFlow. We have one for Rust, which I think is like one guy, and he talks to himself as a special interest group. And then we have one for Java that was just created. We have R bindings. We have Julia bindings even. And I'm certain that there are a number of people who would be very, very excited to see Scala bindings and to also work on them.
I think, Paige, you have a volunteer, yeah?
Yes. So if you would like to create a special interest group for Scala with TensorFlow and start thinking about design work for those language bindings, we would be delighted to think about that.
But you do have Java.
Yes, we do have Java, so JVM support is there.
Yes.
Yeah, which means, so we should have like a Scala person and then also a Clojure person somewhere.
You seem quite enamored by this. I think you should really take the effort to file the first PR request to write the hello world in Scala for TF.
My boss is happy with Java support. He would rather Java over Scala, but
Oh,
thank you.
you're very welcome.
no offense to any Java programmers, but Scala
Yeah.
is brilliant. Go ahead.
Yeah.
Thank you for the talk. It's really great. So I have a question. Like you showed in 2.0 that we can evaluate the TensorFlow variable directly. Does that mean that in 2.0 we got like dynamic graph instead of
Yes.
static?
Yes.
We do.
It's a dynamic graph, and it also means that you. So I mentioned you can do crazy things like adding two numbers together. You can also do crazy things like using list comprehensions to iterate through values of tensors, right? Or you can just use Python dicts instead of like that wonky hparam stuff. So it's really like the same way that you would use Python tooling, just again for scikit-learn or for pandas or for whatever development work you're using, you would be able to do that with TensorFlow as well.
Cool. That's
Yeah.
really cool. Thank you.
Absolutely. Thanks.
Hi. Want to echo everyone else? Great talk. Thank you so much.
Thank you.
I wasn't totally clear on what sections, if not, or if it's the whole data pipeline that TensorFlow JS can handle. Is
Yeah.
it really just like from building to deploying, or is it some section thereof?
Right, that's a great question as well. So TensorFlow JS supports training and also inferencing. So if you want to use it to train a model from scratch, you absolutely can. And the cool thing is too, is that it supports CPU obviously, but it also supports GPU. And that's like kind of scary in terms of how much it heats up your laptop if you have a laptop that has a GPU that it supports. But you can train in a browser like a bunch of data using the GPU in your laptop. And then inferencing, obviously, like you're able to do the sort of piece where you send in a picture and it gives you a response, or you send in a JSON blob and it gives you back a response. You're able to do that as well.
Cool. So is that just all in JavaScript then, or is it like you create in Python, load the model, and then like kind of tune the model?
So the path that we usually see is creating a model in Python and then exporting it as a saved model and using it in a JavaScript capacity, but you can train in JavaScript. So it's Keras-like syntax within JavaScript, and there's even a book that was just recently released by Francois Choulet and the TensorFlow JS team called Deep Learning with JavaScript. So strongly suggest you all take a look. It's good.
And if you love Swift, you can actually write TensorFlow in Swift as well.
Yes. And Jeremy Howard, so the
Yes.
FastAI creator, he historically, his course had been taught using PyTorch, so FastAI, using PyTorch. The next iteration is using Swift for TensorFlow. So it was kind of cool to see, like he was a TensorFlow person and then he was like, well, why is this usability terrible? I'm gonna go over here. And then like, now he's back to TensorFlow. So that's cool.
Take one last question.
Yeah, I'd like to ask just a very high-level architecture question on your considerations when you want to use TensorFlow with very large data sets and also with structured streaming data coming in via Spark.
Mm-hmm. Yes, so I think I mentioned before, at Google, everything is at scale. That feels like a cliche to say. So right now, I think most of the support is for streaming data. And then also we have a great deal of support for Apache Beam. We're attempting to build out friendlier interfaces for distributed training with Spark. But for 2.0 specifically, for the original TensorFlow, for 1.x, it's there, and it's landed. But training with Spark is feasible, and I believe Databricks has a solution for that.
Yes.
Yeah. Awesome.
Yeah,
Thank
we
you.
do have distributed training using Horwood, so you can actually use you can train your model distributed
Yep.
with TensorFlow or Keras or PyTorch anywhere, and uses Horwood as do that.
Yeah, and Horovod, so Horovod support for 2.0, I don't believe it's landed yet. I think we're almost there, and I do know that it's launch criteria for our official release. So whenever, right now we're still on the alpha for 2.0, but whenever the official release happens, Horovod support will exist.
There is a talk on Thursday, I believe, on Project Hydrogen, which is the next version of how far we actually got with Horwood. So you might want to attend that. You'll get some more insight into it. Okay. Well, give a big hand to Paige Bailey.
Thank you.
On to our second speaker is Madura here.
Thank you.
Ready? Let me just introduce you. All right, guys, we have our second speaker, last but not least. Now, today, if you were to actually go to any of your big data conferences like this one, you will invariably hear that machine learning is actually changing the world, right? Now, whether you believe in that hyperbole or whether you believe in that hype is another question. But at some point, you're going to probably ask yourself, how are you going to build a machine learning team, or where do you actually start? What sort of data sets would you actually use, or how do you actually scale a particular team? Those are the questions. That was my time, huh? Just like a racing flag. And those are the questions you're going to ask if you're actually going to build a team. And to give us particular insights, we actually have Madhura Dahundakar. She is the project lead and also leading all the machine learning and deep learning efforts and data science efforts work there. And she's going to tell about how to scale and how to worry about those questions. So please give a warm welcome to Madhura.
Okay. We're going to spend the next 2 minutes reading through this first. Repeat after me. This presentation may contain, come on. No, I'm just messing with you. So the lawyers need me to show this before I say anything. And all this is saying is anything I say in the next few minutes, you cannot hold me to it. Deal? Yeah? Okay, let's do this. So the way I've structured the next few minutes is I'll go over a quick introduction of my background, what gets me going. We'll walk through one example of a 0 to 1 product journey that we did in one machine learning area. Vision is where I'm picking the example from. And then I'll end with a framework that we've been using by doing multiple of these 0 to 1 journeys in different areas that we've abstracted away. So hopefully many of you will find many useful bits that you can take back to your teams. You can read up about my career background on LinkedIn. A quick view, Sun, I was responsible for Java. If you love it, good. If you don't, sorry. Sorry for the verbosity. But I remember the time when we went open source. I still vividly remember my first blog post that I posted. It's not there on the Oracle archives anymore. I looked for it, it's not there. But I left Sun before Oracle took over the company. Then I moved to Adobe, where our team built a version 1.0 product for product designers. It failed. So I moved on, went to Workday, where last few years I've spent mainly building out their ML product portfolio. So various applications across multiple areas, vision, language, anomaly detection, because of our diverse application suite. I'm going to share a quick story so you understand what helps me thrive when it comes to my professional life or my hobbies or personal life. In March 2006, I used to hike. I was an outdoors person. How many hikers in the area? Okay. How many of you are from Bay Area? Raise your hand. Okay, all right. So I know which references I need to add, non-Bay Area lingo too. So Mission Peak, holy grail of Bay Area hiking. For those of you who don't know Mission Peak, it's a 2,000 feet hill in a sense. It's pretty intense though. So if you're in the area, you feel like an intense hike, go for it. So I used to do those and walk around. One of my friends came up and said, hey, do you want to go to Mount Shasta? I had never done climbing before. I did not know what a crampon looked like. That's what it looks like. I said, oh, how hard can it be? Let me go hike up the mountain, right? With some random shoes. So we went up. I rented all the equipment I needed. And to my surprise, I was able to summit Shasta the first attempt that I did. Anybody does climbing or is aware of it? Okay, all right, so the time at which I was at the summit, 3 p.m. If you know climbing, that was very stupid. I shouldn't have been up there beyond worst case scenario, noon. So first timer, did mistakes. It was painful to come back down. Snow was so soft, it was right up to my thighs, so I don't know how I got back to the parking lot, but somehow I made it. So that whole thing made me want to do it more. Suffering, we all love it, right? Yes. So I kept on doing it, Shasta, Whitney, some other mountains. And one of my buddies, not to stop at that, came to me with an outrageous thought. He said, hey, I'm going to Denali in 4 months. Do you want to come with me? I looked at him. At that time, we were both at the same physical fitness level, mental stamina, everything needed for climbing. And Denali was the stuff of the crazies for us, stuff of the legends. We used to talk about it and say, what are the people that go to Denali like? And wonder. So my reaction, are you crazy? And let me give you some data behind my reaction. Denali is the tallest base to peak climb if you look at all the mountains that are above sea level. Yes, it's even taller climb than Everest. The other big thing with Denali is there is no support. There is no mules, there is no Sherpas, nobody's lugging your shit for you. So you have to not only get yourself up there, you also have to carry everything you need for that entire expedition. Hence my reaction, are you crazy? So I said, hey, go on, I'll cheer for you from here. He went that year, didn't summit, but then he signed up again next year. And it put a seed in my head that he tried it, he came back alive, all pieces are there, maybe I should try it next year. So I signed up. I joined the crazy. And I spent the entire next year training like there was no tomorrow. I also had a full-time job then. And my schedule looked like 6 days of training on a good week. I was doing cardio, muscle weight training. Then on weekends, I would go for backpacking. As the expedition came near, you bump up the intensity, you bump up the duration, and you bump up the load in your backpack for the backpacking. So the main thought I had in my head was, I want to go in prepared and see how much I can go and enjoy the experience and not be in pain. That was my thought. We went on the expedition, and it was a long expedition with a lot of roadblocks and glitches with weather and everything else, like any other expedition. But the way I looked at it was, this is an amazing experience. Let me just enjoy every single day. Every single day, I got out from my tent and said, I'm just going to go and see how far I can go that day. During the hard days, I would break it down further. Let me see if I can get through that next hour. During the really hard hours, there was one section where my guide was like, I will kill you if you do not run through this section, and which was kind of weird. Well, am I going to be alive either ways? But during those hard sections, I was counting 10 steps. That's all. Let me get through the 10 steps, and after I reached there, 10 more steps. And with that, to my amazement, I was standing on top of Denali, July 2010, one of the proudest moments of my entire life. So give me audacious goals, I will give you happy Madura. And that's true for my professional stuff and anything that I take on externally. Now let me share some of the context of what Workday does and the applications that we're into. You're familiar with Workday? How many of you use it or are aware of it? Okay. All right, so most of you know. For those of you who aren't aware, Workday builds cloud software that lets you run your business in the most efficient manner. So we have financials product, we have human resources, analytics, planning, and many more things. And the big advantage that the way our platform is architected, it gave us for our ML efforts is we're all working through the same data source. We're all working through the same security model, all the applications, and we're all working through the same common platform elements, foundation. So it was set up the right way from day one for us to start our ML efforts with. And Workday is used by half of the Fortune 50. There is about 2,600 plus customers. and we have 37 million plus end users that use the variety of applications. Machine learning teams, many of us are in the same building as Databricks, where Jules sit, 160 Spear. So if you're in Soma visiting, come by, say hi to both of us. We're in the same building. And the other locations that we're growing teams is Victoria, Canada, Boulder, Colorado, and Dublin, Ireland. So I'm going to put in that hiring plug: data scientists, data engineers, DevOps, dev leaders, data science managers. If you know any people that want to be in any of these locations doing ML, find me after this. Now, we'll talk about the one example of a 0 to 1 journey that our team went through, and I'll abstract away some of the key elements that now we use for anything new we do in a new area. So the challenge that was given to the team was build an ML service that can scan expense receipts and auto-populate the expense reports application. We were asked to deliver it in 6 months because of competition pressure, something or the other from the sales team. The kind of team that we are, most of us are like me. We said, yes, let's do it. And the first thing we did was, how do we know what success looks like? Defining it very crisply. Where did we want to go? So for us, we wanted to build an ML service that scanned receipts with accuracy greater than 80%. We wanted it deployed in both public and private clouds, because some of our customers use this versus the other, and we wanted to release it for all of our customers. So we defined the win. OCR has been around for decades. I think 1941 was when you see kind of starting of it with telegraphy and reading devices, if I were to stretch it far. But we decided to build our own models because most of the OCR off-the-shelf stuff, it focuses on what you see on the left, which is the wall of text scenario, where there is more predictability, there's more of a rhythm or a flow to those documents. But if you look on the right, a receipt is a whole different animal. If you look at that logo, that could come in any format, color, shape, text, font. You don't know what you're going to get. You see that bar code scanner. You see random wild characters. You see different font sizes or space distribution over the whole receipt. So none of the off-the-shelf was going to work for us, and we had to build our own models. The first obstacle that the team had to deal with was, at the time we built this application, all of our customer agreements did not allow anyone at the company to use the tenanted data, let's say the customer receipts, the expense receipts. And now we have built out innovation service agreements that let our customers opt into features and donate data to get value. But at that time, we didn't have that. So we had to figure out a way, how do we keep our commitment to ethics, unlike some people I won't name, and how do we keep the trust and transparency about data with our customers? How do we do it? And the first thing we tried was we generated some synthetic receipts to the best of our ability to try to mimic expense receipts, and different backgrounds, different text, and tried to do font curvature to call out your crumpled receipts or the blots, the coffee blots on your receipts. So we tried to generate as many scenarios we could think of, but it didn't get us to the accuracy we wanted. Got back to the drawing table, team got together, what do we do? What are our options? And one of the team members said, hey, there is thousands of people at Workday. Why don't we ask them to donate receipts? I bet they have them in their drawers, their pant pockets, their backpacks. And I said, yeah, let's try it. Let's see how much we get. So we launched a receipt contest. We cooked up the UI. The legal team gave us some way to say, yeah, I'm OK with you using my receipt. and stood it up. Guess what the price for the receipt was? Remember, I needed to incentivize people to go through the drudgery of finding receipts, taking a picture, uploading it into this UI, which was above and beyond what you needed to just finish at work. Guesses? Okay, come on, do better. What? Okay. Okay, I'm gonna keep that for the later, for some later. But latest iPhone, it always works. If you wanna incentivize people, Apple products. Never failed me. So keep that tip, if not anything else, from this session. And we did get thousands of receipts, and we were able to get to the accuracy numbers we were looking for. So that was great. I'll go through the ML pipeline and the way we architected our system. Phase one was bounding box detection. So all it did, it was a microservice that detected the field of interest or all the things that we cared about within that document. That's all it did. We used deep learning model using residual networks, which did well for this particular phase. And the output was center of the box, height, width, angle of tilt, and the model's confidence in that output. The second microservice focused on just text recognition within the bounding box. And we used the same models, worked for this particular one also. The output from this phase was text. The most complicated step was the mapping. And this took us a while to figure out what is that right ensemble that was going to give us, for all the fields, the values within that document, because we had to figure out what was going to work. And eventually, we ended up having a mix of rule-based and a few deep learning models, an ensemble that kind of got us the accuracy we wanted for this last phase. Just roughly what it looked like, the blob that you see, that's the service at Workday that essentially stores all the documents, receipts or documents. So it's outside of our team, but our orchestrator down here essentially orchestrated all of our phases. We got the receipt, performed field of detection, the first bounding box detection, then did the parser, and did the mapping through the ensemble, and wrote the response out to Kafka, which was then consumed by the application and UI layers. Another decision we had to grapple with was what deep learning framework to use. Is Paige still around? Any guesses for what we ended up using? Okay, I'll keep you guessing. So before I do the big reveal, we had a specific criteria that we cared about for this particular application. So we did proof of concept with all of these frameworks before we landed on our choice. And what we chose might not match with what you choose because your criteria might be completely different. But it was a MXNet. And the three key factors for us were it did the best when it came to performance at the time that we tested this. This was a few months ago, so I don't know if TensorFlow 2.0 is doing better. We don't know. And the other big thing for our team, we are a Scala house, so our primary two languages, mostly Scala, but Python. Those are the two languages we use, so we wanted something that could support Scala packages. And the last piece was going with a company that was going to be around for a long time so we could get the enterprise level support we want. So those were the three main things that we considered, and MXNet won the race for us, at least. Another element that played a role for getting to the accuracy we need, we have a small data labeler team that helps us with all the supervised learning applications. So they helped us with data labeling, for us the training receipts data set. And as we were iterating through the models, they also helped us validate our accuracy and how we were doing. To zoom out, outside of just one use case, this is the way we've organized all our different pieces for all of our ML services. So this layer, CI/CD deployment, takes care of all of the deployment pieces. So the ML service builders don't have to worry about their services being able to be deployed on public, private cloud. So this takes care of all of that for us. So this thing takes it through the right build pipelines, the test, integration test, and whatnot, to land it at all the covered necessary locations for our applications. The layer on top of that is ML platform. These are just engineering components, the common framework components that are required by most of the ML services that we have built. So model management, model versioning, deploy monitoring, tooling. So anything that's required, that's common across all of the ML services, we essentially build it out over here with APIs. And I'm only showing the 3 microservices associated with the product we talked about, which was OCR for expense receipt. But so the field of interest detection, the parsing, and the ensemble, these 3 boxes, these are all microservices that essentially orchestrator gets the necessary streams through and pass out the output. And they're designed in a manner where not just these services, but all of the ML services we build, we want them to be looked at as Lego blocks, and in future being able to kind of pick out the needed pieces for more and more use cases across our ecosystem. And then the left part is just exposing it to the application and the UI layers. So after 6 months of getting past all of the roadblocks, we were able to ship and get the accuracy that we wanted. You remember what number we were targeting? 80, okay. The gravy was, I didn't put the real number, but we're more than 90%, but in reality, we're hovering around 95% in production for the last few months, so very proud. The team did really well. So that's one of the 0 to 1 journeys in one ML area vision for our use cases. Now, the framework that we've gone through multiple of these in different areas, language being another one, and anomaly detection being another major one. And we've kind of figured out what to do and what not to do, what pattern to follow whenever we go after a new ML area. And for you to begin well, we use the START principle. S stands for select your one win. Don't go after any more than one. If you're doing something in a new technique or a new area of ML techniques, only do one thing before you move on to scaling. And the key here is being very precise about how do you define the win, the way we define it for the OCR example. You should be able to tell when you reach your end finish line whether you were successful or not. It should be very objective. So be very specific and make sure all your stakeholders align with how you're defining win. The T stands for team. Put the right team on this first win. One key element is picking the right technology leader. That's shepherding the first one. The 2 elements that are critical here are you want somebody who's battle tested, who has done 0 to 1 before in new technology areas. It doesn't necessarily have to be ML, but somebody who's battle tested on going in a completely new path in a new area, and of course a technologist. And the other key piece that, especially with all the hype around ML, this is one of the key elements for the leader that's put on this. They need to be able to talk the tech and also talk the exec. Because most of the companies that I talk to that are trying to go in this area outside of the big boys CEO and his staff is extremely interested in whatever the hell is going on in the ML group. So you need someone who can translate whatever is going on there in a manner that they understand, they can consume, and they can keep that patience till you get through whatever you need to get through, because generally they'll want results tomorrow, because all the analysts are knocking on their door, hey, what are you doing about this ML thing? There is so much hype. So picking the right leader for that first win, keep the team really small, less than one pizza pie. And another critical element, the time box it. Do not go beyond 6 months. Your goal here is to speed up the learning within this new area. And you have to go through that one cycle. Doesn't matter what win you pick. You want to go through that first win cycle as fast as you can, so you internalized all the learnings from that first thing before you can do more in that new area. So those are the key elements. A is articulate and align. Articulate your win, the game plan on how you're going to move through it, and make sure the leader is keeping your stakeholders aligned on where this is at. Even if it's 6 months, believe me when I say if you do not talk to them for 2 weeks, it'll feel like too long. In case you pivoted, in case you changed completely what your pain area that you're going after, or your value hypothesis changes, you want to keep them close and with you on that emotional journey so that there is no surprises and they keep the investment strong in the area. Rally and support your team. One thing I want to call out is when CEO and the exec team is saying, we need to do something about this ML and fast, and get the whole company energized around it, the ML team is going to be bombarded with so much noise from everywhere in the company about, hey, let's do that, let's do this, let's do that. And keeping that team buffered, protected, finding some way to get the noise away from the team, it's very important. And support, that'll probably be the main piece, and the regular unblocking the team, keeping them focused, and getting them what they need. Please take shortcuts. And if you have senior engineers, architects that are involved with this first win, their instinct is going to make them want to build it right. Okay, that's their muscle memory, that's their DNA. And then which is where you'll have to help them see the bigger picture where, hey, it's not our goal to build something right here. It's our goal to speed up learning for how do we build something in this new ML area. So in spite of their instinct, please help make sure your team is not building out things that are kind of known and they know how to do it. They can do it later, scaling or stacking their boxes well, in a sense. Your goal is to speed through this first win as fast as you can and get all the learnings out as fast as you can. So please accrue that tech debt for the first win. To summarize, select that first win. Team, make sure you pick the right leader who can talk up and down, and keep a small team size. Time box your first win. Your goal is learning, not necessarily that particular win. Make sure you're keeping your stakeholders aligned on your win, your game plan. It is very critical. You'll be really busy, but don't skimp on this one, whoever is leading the effort. Rally and support the team. Protect them from noise that's going to be coming at them, and make sure for that first win, the team is taking shortcuts. Now that you've delivered that first win, you can start thinking about, okay, how do I scale now that I understand what it involves? For scale, it's simpler. Get is the principle we are using. First and most important thing, get credit for that win. Make sure the entire company knows about the success, because that's going to build confidence, and it's going to get you all the investment now that's that will be needed for the platform elements and some of the scale pieces that will be critical for building. So get that credit, gather more capital investment from your senior stakeholders, and now you can start thinking about and investing in establishing repeatable processes, the platform components, generalizing some of the pieces you might have built in an ad hoc manner. So this is where now you start establishing more longer term stuff. And make sure you transfer and apply the learnings from that 0 to 1 to anything that you're doing. And one good way I have seen this happen intentionally is whoever was involved with that 0 to 1 before, make sure you pull some of the people from that crew on anything you're trying to do, and then add in people that haven't experienced this before, so that you're growing your organizational muscle by allowing newer people to go through it, but you don't miss out the learnings and they don't repeat the same mistakes because you have some of the members from that first win in as part of the crew. But split them, the 0 to 1 team, split them across how many ever things you're trying to do. To summarize, get credit for that first win, get that extra investment, now invest in the repeatable processes and platform elements, and make sure you have the right team mix for additional applications so you can transfer and apply all the learnings you got from 0 to 1. Now that you have the secret sauce, start and go get them. Thank you.
Thank you, Madhura, for that insight and inspiration, not only in scaling mountains, but also scaling your team and coming up with products that go from 0 to 1. Now, if you're audacious to mount or climb Mount Denali backwards, you can ask some questions how to do it. Anybody? Yeah, can you come down to the mic, please?
Yeah, well, my question is along the lines of, you're talking about the team, getting the right people on the team to get something done, right? As quick as possible so that you can show the value to the business. Question is, recruiting is always an issue. Finding the right people, because at times you don't even have the people in the house. You need to go and find them.
Yes.
So what kind of a strategy did you use to get the right people in your organization?
So not all of the way we're looking at, let's say, data scientist is a hot supply and demand dynamic right now, right? I think my recruiter was telling me the average tenure for a data scientist right now is 11 months. That's the time it takes someone to ramp up and start contributing. So some of the things that we are doing, because churn is going to be there on your team, just accept it, just because of the way market is. And one of the ways we're fighting that is by geographically dispersing. So that was one strategy we are using to try to fight that, so that some of the pockets will at least be more stable than the Bay Area ones. Because we went through that, where trying to build out a portfolio and there is that constant churn of talent, regardless of how much ever fun it might be. And it's not easy. The main thing that we're doing is how can we find different locations that have different variety of stability, and then overall system stays stable. Yeah, but there's no shortcuts to the talent problem right now. If you find any other solutions, please tell me.
Sure.
Yes.
Thank you.
Yeah.
The world of poaching is legitimized in the Bay Area.
Yes.
Thank you for the talk. I had two questions. One was, you said that you had thousands of receipts collected from the employees. It seems like you used a deep learning model. I'm just wondering, how come thousands? And second question was, which is the follow-up, that what about the labeling of these bounding boxes? Because that seems like a very arduous task to do. So how did you solve that problem as well?
So it is an arduous task to do, and we treat our data labeling team like precious people that we don't want to leave the building ever. No, we treat them really well. And the only way I've seen dealing with just the monotonous nature of their function is they take on some projects that are outside of DAS if they have the skill set, and we kind of try to mix it up for them because, as you said, it's just, I don't know how they do what they do. And I'm so thankful to them. That team is probably the team that we treat like a flower that's very fragile and needs to be kept happy, so to speak.
And the first question was that about the data set size, I thought like you said something like 1,000. It seems like for the deep learning that's
Thousands.
like
Yeah, so I think we
hundreds of
got
thousands.
about 50,000 receipts. That was sufficient. You'll be surprised as to how, at least the meals receipts and some of these, right? Even though you saw there was variety from wall of text, it still captured
Got it. Thank you.
enough, variance.
Well, you can take 50,000 receipts and augment the text. It gives you 100,000 receipts. So, sometimes there is a myth that for deep learning you need loads and loads of data, but you can actually augment the data by just changing the
Generate
nature
more.
of the
Yeah,
text.
like
and just
augmented.
generate.
Yeah, sure. Thanks.
Okay, next please.
Hi, thank you for the presentation. Quick question, why you went and split into services, different services, like reading the receipt, what's the benefits? And the second question, how you run the model, whether you retrain the model, how you do it in a production way so it become like stable and sustainable.
Okay. So for the first question, there is additional use cases that where I would be able to use let's say the bounding box detection microservice as one of the microservices. We have use cases that need to deal with invoices. We have use cases so with the application suite, there is so many use cases and different document types. I want to leverage as much as I can and reuse. And that's just one example of where we would be able to reuse. What was the second question? Sorry.
How you run the model in production environment.
What do you mean by that? What specifically?
Whether you train the model, how you keep it stable, because with the time they keep doing the weird bonanza stuff, you have to load to original source code. How do you deal with the stability of the environment?
We deploy the models, we keep track of the versions, and every single application that is deploying models, they come up with the metrics they care about for that particular model, and then we have monitoring and some checks and balances, where as we're training on the newer data and the model is getting up to the next version, we check certain parameters before we decide whether the new one gets deployed at runtime or we stay with the new one. So that's the way we
And if you actually want to find out something more about how you actually manage the entire cycle, come to the keynotes tomorrow. Okay? Thank you. I'm trying to plug things in here.
Yes.
Hi, thank you again for the talk. So my question is, when you were working on that OCR project and you had that 6-month time frame, looking back retrospectively, what would you say were some of the trade-offs or sacrifices that would definitely be very worthwhile and like probably generalize well to other teams, projects, whatever?
I'll tell you what we shouldn't have done.
Oh yeah?
So our team is just Scala fans. And in the beginning, we did not allow Python in the house. And this was one of those early days where the team actually went through the effort of models were in Python, they were converted in Scala before we deployed. If we hadn't gone through that, I think we would have gone to production faster. But that was one thing that made us realize this is stupid. And then we kind of convinced everyone that, hey guys, we need to do both. Unless there is really strong scale requirements, Python will do. There is no need for us to invest effort in doing that. So that was the don't do it. The things we did was we didn't think about the platform was getting built because this was one of the first 0 to 1 use cases. So we didn't worry about depending on any of the generalized platform elements. We just cooked up everything on its own. It was a standalone service with everything that it did on its own, didn't leverage any of the platform elements, because those dependencies would have caused delays to the production cost. So whatever was not ready, we just made it as fast as we can. So that's one trade-off we did. And then later on, we invested in then moving those pieces and hooking them up with the generalized platform elements that were ready. So that was one specific one that we intentionally took the shortcuts and said, let's just build it as if it's a two-person startup.
So just kind of like home rolling the different, what would have been like external dependencies team-wise?
Yeah.
Okay.
Yeah.
Cool.
So we just didn't take on any dependencies. We built everything we needed, just in the Band-Aid manner. Yeah.
All right, thank you.
Yeah.
Next.
Hey, great
Hey.
talk. Had a couple questions. You talked a little bit about your data labeling team, and I was kind of curious, like in the context of your 6-month time frame for delivering this application, what percentage of that would you say would be characterized by the training data A collection and then B, the actual annotation and labeling, and maybe some notion of the iteration post-model training?
Okay.
And then outside of this particular project in general, I'm just kind of curious, you'd said you treated your data labeling team extremely reverently. Kind of like how much is that is a pain in your workflow for delivering these applications, and what does that represent in terms of your velocity to deliver machine learning applications?
Okay. So for this particular instance, because we didn't have the legal agreements, just getting to a point where we had enough data set to get to the levels, that took us 2 months. So the first 2 months of project, we did the synthetic generation, and then we're like, okay, this is not working. Talked to the execs, said, hey, can we do this? We had to talk to the privacy legal thing to figure out whether this was even kosher, to collect receipts even from internally, worked with them to draft the legal doc, so to speak, to be able to do that. So that took us 2 months. And then after that, we ran to use the last 4 months to finish up all the iterations and productizing it.
So you'd say like over half was invested in the actual labeling. The first 2 months was simply just the legal framework to allow you to collect the data.
To figure out, how do we get data. And the labeling, they've never taken more than 2 weeks. And the way we extend that team based on what we need, we hire contractors. So there is a pipeline that's always ready in case we need to make that team's capacity elastic. We're not allowed to use any of these platforms, Mechanical Turk or Crowdflower, Figure 8, whatever their new name is. So we have to depend on the internal stuff, and the only other thing we can do is extend it by getting additional contractors.
Awesome, thank you.
Hi, thank you. I really enjoyed your anecdote about the hiking. I had a question because it seems your team had a pretty nice way of solving like one of the common problems of how to get enough data for your training and validation set. So did you face any issues because your training and like validation sets came from all entirely within the company? So like it might not have been the most representative set of like all the different receipts you get. And then you mentioned that your like engine for actually, mapping like date fields and all that used a lot of rules. So did you use like a rules engine to sort of accommodate for some of the deficiencies in the fact that your training and validation sets didn't represent the entire
Yes, definitely.
population?
So incidentally, date was a thing that uses the rules piece. That's one of the fields. And there are some instances, for example, some of the hotel receipts or airline receipts could be way varied. So we tried to find additional variety within that. And then wherever possible, we kind of used the rules if we knew exactly what that was going to do. And even the way the ensemble works is there will be multiple models that will try to resolve it. And then at the end, we compare scores. And then whichever did the best, that kind of becomes the final.
Got it.
Amongst even rule-based and the other models.
Perfect, thank you.
Yeah.
We'll take one last question, and then Madhura is going to hang around so you can talk to her offline. Okay, last one, right? Go ahead.
First, nice talk. You speak about the label team. So I was wondering, how exactly are you guys organizing in data science team, and what are the pitfalls of split responsibilities?
Yeah. So we've evolved our organizational structure. In the beginning, the team was small. So it was based on initiatives. So there were data scientists, data engineers, everybody needed PMs that were going after an initiative, let's say. So that's how we were organized. And everybody reported to the same manager. But last year, as we got to scale, we shifted it where data science and architects, that's a centralized function. We have product pillars. I lead a couple of the product pillars. There is a couple more people that are leading the other product pillars. And we all have data scientists, architects embedded within our initiatives as much as possible. We try to keep the same team on the larger product domain, but there is flexibility to move data scientists around if the ebb and flow of project start and is different and they're looking to do different things. So now, as the team got larger, we made them centralized, and I do anticipate us moving back to the earlier model, which is, let's say, the financial product, ML product team will probably have their own data scientist and will dissolve the central function. So I see it happening probably within a year or two. Yeah.
Okay, last one. Make it short.
Hi, I have a question on model as a service. So where are you running your microservices and what platform it's running on?
So the ML platform that I showed, that is all internally built. And if you're talking about the bottommost DevOps level, yeah. So we have our own data centers, which is that private cloud, which we have a ops team and everything. And over there is, we also have an option to do virtualized. VMware is what we use for that. And then for the public cloud, we do Amazon right now.
And your microservices is written in Scala or Python or?
Depending on the app, this or that. But most of them now, if it's Python and the scale works for whatever that application needs, we just keep it in the language that it was written in.
For your cloud, do you use Pivot Cloud Foundry or some Amazon?
We have to cut off. She's going to hang around. You can ask her as many questions as you can. But please give a big hand to Madhura for that insight. And remember, want to thank the Databricks diversity committee to actually organize this particular event. And we have lots of surprises for you tomorrow and Thursday, and lots of great sessions for throughout the summit. So enjoy yourself, be safe, and thank you all for coming and your support for the community. Go Spark.